Good day. Today I will talk about a half adder and a full adder. A half adder or a full adder basically do a summation to two binary values, to two single bit binary values. For here we have a half adder. It takes two inputs, two binary bits, A and B, and output also two binary bits. One is a sum, and another one is a carry out. The carry out, what does the carry out mean? If the two binary values are 1 and 1, the sum would be 0, and there is a 1 bit overflow and goes to the carry out. This is only for a single binary bit, and we can have another adder. This time it is a full adder. The difference between a half adder and a full adder is that the full adder also takes a carry in. Similarly, A and B, sum, also the carry out. You can cascade multiple adders. To perform hair bit binary addition. Cascading. Okay, let's first focus on the half adder. Let's draw the truth table of the half adder. Input A, input B, and sum, carry out. There are two input bits, so there would be 4 rows, which means 2 to the power of 2. 0, 0, 0, 1, 1, 0, and 1, 1. 0, 0 plus 0 is the sum is 0, and the carry out also 0. 0 plus 1, sum is 1, carry out 0. 1 plus 0, sum 1, carry out 0. Here we got 1 plus 1, which is 1, 0. The leading one is overflows to the carry out, and 0 remains in this digit. So here's a truth table of a half adder. Okay, let's see how to implement this in using the gates we have already seen. Let's see the sum. The sum is basically a exclusive OR, XOR, and the carry out is a AND. XOR. So the half adder could be implemented using exclusive OR and AND gate. Let's see, exclusive OR. And AND gate. A and B. Here, the XOR outputs to the sum, and the AND gate output to the carryout. Here's our gate level implementation of the half adder. Let's go to our HDL file and run it in our hardware simulator. Half adder, half adder here. Okay, let's put this set by set. Our drawing. First, let's have a exclusive OR gate. About A, B, out, about. AND gate, and about. Carry. XOR add. And see, save and see what happens. Run PowerShell here. I already have a PowerShell. Close it. Close them all. And open up a new PowerShell. Hardware simulator. Load our half adder. Why not loading? Alt is not a pin in or a ball. Typo. About. Okay, test the script. Half adder. Cool, it passed the comparison. So let's move on to the full adder. Full adder. Okay, let's draw a full adder. AB. In addition to the AB, it also got a third input, which is a carry in from the previous stage of adder. It has a sum and also carry out. So let's draw the truth table. Three inputs, A, B, and CI. Two outputs, sum and carry out. So we got three inputs. The number of rows would be 2 to the power 3, 8. Truth table. Maybe it's better to use another technique called a K-map. It is more convenient to analyze boolean arithmetic with more than 2 inputs. Let's try this. Use a K-map. Just erase them. No. Can I selection? Okay. Hold a shift and use mouse to select and delete. K-map. How to draw this K-map? I remember that's like this. We have A, B here and C down here. The combination of AB value start from 0, 0, 0, 1. This time, like a Greek code, we have a 1, 1, and 1, 0. For C value, say carry in CI value 0 and 1. For AB and CI are all 0. Of course, that's 0. Let's draw another K-map at the same time. Easy to calculate. So this is a sum K-map, and then we also got a carry out K-map. Karnaugh. It should be named after a mathematician whose name is Karnaugh. Okay. A, B, and C both are all 0, 0, 0. So when CI is 1 and AB are 0, the sum is 0, no carry out. When AB is 0, 1, no carry in, so that's 1. When B is 1, CI is 1, so it is 0 here and 1 beta carry out to here. When AB 1, 1, CI is 0, so at this digit it is 0, 1 beta carried out to the next digit. 1, 1, 1. In this case, 1 left here, also 1 carried to the next digit. For 1, 0, so at this digit 1 and only one bit is 1, so no carry out. 1 0 1, here is 0, 1 bit carried out. So let's see how can we, they are all separated, so we need to do the maybe do this first. This one is easier because ones are located next to each other. We have those two and those three co-located. So for this blue line, we have a CI and bracket. So how to express this? Should be O A O B. Whenever there's one, at least one bit is 1, the output is 1, so A or B. Let's see this the green part. The two parts are connected using O. The green part is A and B. That's a case where both A and B are ones across 2 rows. Yeah, that's the equation for the carry out. Let's go back to the sum. Headache. Yeah, let's do the do this one by one. The first line, let's focus on the first line. First line carrying is 0, so we have a which color? Let's use red. We have a CI bar because it's 0 and separated, annoying. A bar 0 and B. A bar and B, or A and B bar. So let's look at the second row. Let's move this. Need a bit of space. Second row, let's use color green. Use black to connect. Color green. Second row is CI. Yeah, CI and all 0, so that's A bar and B bar, or all ones, so A and B. This should be able to simplify it. Let's see what this. When A and B are different, so take the value. So this is when different, so this is A exclusive of B. I mean this part. And when they are the same, they are sim is the opposite of the exclusive OR, so it's inclusive OR. Of course, there's no inclusive OR. This is called XNOR, exclusive no. Like this. XNOR. Hey, do we have a XNOR gate in workshop 1? XNOR. Seems no. But it is easy. It is just an XOR followed by a NOT gate. So this time it should be easier to draw it. Let's do this. For the first layer, we should have a how to highlight. In the first layer, we would have this part, A exclusive or B, and this A exclusive or B, then not. That's the first layer. Let's do this. Have a thinner pen. Exclusive or sorry. That's a exclusive or faded by A and B. Output, let's call this point as where 1. Okay, that's this part. And do that part. That part is also exclusive OR, and do a NOT, so we can just take some take this output and put a NOT gate. Call this NW1. The inversed value of W1, and fade it. Okay, we have those two. Let's do something with this C1. Okay, this part is CI. Do a NOT gate because it's a bar NOT gate, and take AND value with W1, and call this W2. Okay, for this part it's no bar, so take original value, and here is NW1, W1, NW1, also AND gate. Here we got call it W3. At the end we would have a OR gate. This is our sum signal. Okay, a bit complex. I hope it works. This one should be easy. We have first layer. First layer is A or B, and this one A and B. The second layer is this part, and the fourth layer is here. Okay, let's do the first layer. This is all A. A, B, A or B, and then we have A and B. Oh, so difficult to draw it. A or B. That's first layer. The second layer is to take an and. To CI. Second layer. 1, 2. The third layer would be great all. Oh, so great. It all takes this output, this part, and that part. Is our carry out. Okay, name the intermediate points. Let's call this C1, C2, C3. Okay. Let's try to implement our full adder. Full adder HDL. Whiteboard. First layer. Let's draw some ABOUT about. A equals something, comma, B equals something, comma, out equals something. Okay, let's copy this template and put it here. OR gate. No, not OR gate. Exclusive OR. XOR. The input is A and B. The output is W1. After that, we would have a NOT gate. NOT gate is in NOT. In is CI. C? C. Out is forgot to name this. Called CNC. Not C. Okay, this is our first layer. Second layer would be another NOT gate. Copy it. So the input is W1. The output is NW1. The third layer is two AND gates. Copy this template. what's the input? W1 NC W1 and NC. Output is W2. Another AND gate input NW1 C. Output is W3. Okay, and the fourth layer is OR gate. Also copy this template. So what's the input? W2, W3. Easy. Out is sum. Okay, here we have implemented the sum part. There is a carry out part remaining. So call this sum part. Carry out part. First layer one OR gate and one AND gate. Copy the template. What's the input of OR gate? A and B. The output is C1. And see the AND gate also A and B. The output is C2. Okay, see the second layer, only one AND gate. Copy this. The input C1 and CI and C1. CI is the C in this case. C1. The output is C3. Okay, and the third layer is great OR. Great OR gate. Let's copy this. OR gate C3, C2. C3, C2. What's a carry out? What's the name? Carry. Okay. That's it. I think. I hope it works. Oh, finger crossed. Wider. No syntax arrow. Syntax. SYNTX. Syntax. Wider. Okay, run to the end. Oh, keep going. Good. Okay, successfully done. Okay, ladies and gentlemen, this is my note today. The implementation of a half adder, and also a full adder. Thanks for watching my video. If you like it, please thumb up.